I'm here to explain the two questions that were posted about the 6.3 homework. So let's get started. The first question was 43. 43 wanted to, you have an exponential function. The dependent variable is multiplied by 2.5 for every 1 unit independent, and the value of the function at 0 is 8. That's giving us two pieces of information right there. I personally would write an equation for this. And so here, when it's saying the dependent variable is multiplied, it's multiplied by that. That means that that is my constant variable that is being multiplied by. So that's my b is 2.5. And then when it says that the value of the function at 0 is 8, that's telling me my a value has to be 8, because remember, that's your initial amount, or when x equals 0. So I could have my equation a b to the x is now becoming y equals 8 times 2.5 to the x. And so now that I have that, I asked to graph the function with the given description, and then compare that function over to the next one. So to graph that one, I would personally possibly make a table for that. And it says to graph it from 0, 1, 2. Well, I already know that 0 is going to be 8 based off of this once again, or I could have plugged in 0 right here for my x. Then I could plug in 1 for my x and 2 for my x to get my other answers there, which is really just me multiplying it by 2.5 as well. So if I do that a moment on my calculator, so let's see here. So 8 times 2.5 gives me 20, and then times 2.5 gives me 50. So then I can go ahead and graph that a minute. This would be my, sorry about that. Let's move this up. So this would be then 0, 1, scratch that. This would be 1, 2, and then I have to get it up to 50, so I'm going to go by tens. 1, 10, 20, 30, 40, 50. So then I would plot my points. So 0 is about 8. Let's see if I can get this in here a little bit better. I don't know how well that shows up. All right, and then I have 20, and then I have 50. So then I want to curve those a little bit. Not perfect, but you get the idea. Compare it to the other function that's up here a minute. So if I'm going to compare that, I can see, first of all, the a value in that equation I just circled is 0.5, while the a value in this one was 8. So this function g is going to start at 8. Other function starts at 0.5. So g starts at a smaller amount, which I'm not going to write up on this. Another thing that I could mention is then the b value. Here on this one, we're multiplying by 2.5 on our g function, the one that we just graphed, but the one that's up here, my b value is 4. So it's getting multiplied by 4. If I'm getting multiplied by 4, then I'm going to have my graph increasing at a higher and faster rate than this graph right over here. So I would say g, no, I'll say f, because that one's the f of x. F of x, see that right there? F of x is growing at a faster rate. I could be more specific and say a rate of 4, while the other one was g was graphing or multiplying at 2.5. All right, hopefully that answers or clarifies those questions on that one here. Let's see here. Modeling this question, I'm going to just move it a little bit. All right. So let's see here. graph the function, describe the domain in range. So once again, we are given our equation to use. So I personally would just make a table. This one is X is the number of 20-year periods in for the population of a coyote, and I don't want to personally, it doesn't make sense to have my X values be anything that would be negative numbers. Like, okay, before I was kind of starting to track this population of coyotes is kind of what the negative would be. So I'm going to just do 0, 1, 2. Could potentially go out to 3. We'll see how big that gets in a minute. So if I plug in 0 into this function for that, I would have 3 to the 0 is 1, so I'd have 1 times 15 is 15. And then I'd have 3 to the first power is 3. 3 times 15 is 45. And then I'd have 3 squared, which is 9. And then I'd have to do 9 times 15 to give me 135. All right, already we're getting pretty big there. And then I'd have 3 to the third power, which is 27, and then times that by 15, and that would give me 405. So then to graph that, I'm going to graph it up here a minute. So to graph that, I'd have 0, 1, 2, 3. I'm not labeling very well here, but you get the idea. And then I have to go up to 405, or if you just chose to go up to 2, that's fine too, but I'm going to go up by hundreds here. So 100, 200, oops, that didn't work. 200, 300, 400, 500. All right, so then I'd have 0, 15 is going to be really low down here. 145 is almost halfway. Sorry, these aren't perfect, but you get the idea. 2 would be 135, and then 3 would be 405. So then I could connect them with a line, which, yikes, once again, not perfect, but you get the idea. So the domain on that function is, remember your X values. What can I plug in for X in this equation? In this case, because it doesn't really make sense to go negatives, I would say when X is going to be greater than or equal to 0. Once again, I can equal 0 because that's going to be like the starting amount of my population. My range, and I could do decimals potentially. My range here is always your Y values technically. Yep, it's using Y in the equation as well. See how it is only above this x-axis. I'm only going above this x-axis. You can never touch it. Remember that it gets closer and closer, but it won't touch it. But in this case, because I'm starting at 0, I'm not going to say Y has got to be greater than or equal to 0 in this case. Well, actually not equal to, but greater than 0, because I started at 15 right here, and it's only going to get bigger from that. So Y is going to be greater than or equal to 15 should be my answer for my range. And so that kind of goes along with find and interpret the y-intercept. If I want to find and interpret the y-intercept once again is when x is 0. 0 is the number of 20-year periods. So there's no 20-year periods where the population hasn't tripled every 20 years. So it's just like the starting amount. The starting, is it wolves? No, coyotes. Coyote population is 15. That's for B. And then C, I get to use my equation that I created, or no, that they give me, but the trick is that says we want to find the coyote population in 40 years. But X represents a 20-year period here. So 40 years is actually where X equals 2, because 2 times 20 is 40 years. So I'm really just plugging in 2 for X, and so I already have that answer right there. So that would be 135 is going to be my population for C. Once again, if you need further questions on this, please send me an email so I can see it and respond to that.